Think about this. It's a January morning in Minneapolis, and your phone shows the temperature is -10 degrees Fahrenheit. Later that day in Miami, it's +75. Both numbers describe a temperature, but one of them sits below zero. How do we make sense of numbers that live on both sides of zero, and how do we measure how far out they really are? By the end of this video, you'll be able to compare any two integers, find the opposite of a number, and simplify expressions using something called absolute value. Let's start with the number line itself. Here's the rule that runs everything. On a number line, numbers get bigger as we move to the right and smaller as we move to the left. Zero sits in the middle. It's neither positive nor negative. So let's use this to compare some numbers. Which is bigger, 14 or 6? Well, 14 sits to the right of 6, so 14 is greater than 6. Easy. Now try a trickier one. Is -1 bigger or is -4 bigger? Let's find them both. -4 is 4 units to the left of 0. -1 is just 1 unit to the left of 0. So -1 sits to the right of -4, which means -1 is greater than -4. Here's the part that trips people up. With negative numbers, the one closer to 0 is the larger number. -1 is greater than -4, even though 4 looks like the bigger digit. Position on the number line always wins. Let's try one more. Compare 2 and -20. 2 sits just to the right of 0. -20 is way off to the left. So 2 is greater than -20. Any positive number beats any negative number, no matter the size. Now here's a beautiful idea. Look at 5 and -5. They're both exactly 5 units from 0, just on opposite sides. We call these two numbers opposites. The opposite of a number is the same distance from 0, but on the other side. So what's the opposite of 7? 7 units to the right of 0, flipped over, gives us -7. And the opposite of -10? 10 units left, flipped over, becomes +10. This gives us a new symbol meaning. In algebra, a minus sign can mean 3 different things depending on where it sits. Let's untangle them. Let's see that third meaning in action. Watch this expression, the opposite of -6. Written out, that's a minus sign, then -6 in parentheses. The inside is -6. The outside minus flips it, giving us +6. So the opposite of -6 is 6. Together, the counting numbers, their opposites, and 0 form a set called the integers. That's every whole number, positive or negative, all the way out in both directions. Now for the star of this video, absolute value. Here's the question that leads us to it. How far is -5 from 0? 5 units. How far is +5 from 0? Also 5 units. Distance doesn't care about direction. The absolute value of a number is its distance from 0 on the number line. We write it with 2 vertical bars around the number. And because distance is never negative, the absolute value of any number is never negative. So let's simplify a few. The absolute value of 3 is 3. It's 3 units from 0. The absolute value of -44 is 44. It's 44 units from 0. And the absolute value of 0 is just 0. Now here's where careful reading matters. Watch what happens with a minus sign outside the bars. Look at negative absolute value of -8. First we simplify inside. The absolute value of -8 is 8. Then the minus sign outside flips it, giving us -8. Let's put this to work by comparing two expressions. Fill in less than, greater than, or equals absolute value of -5 compared with negative absolute value of -5. Simplify each side. The left side, absolute value of -5 is just 5. The right side, first the inside gives us 5, then the outside minus makes it -5. So we're comparing 5 and -5. And 5 is greater than -5. So absolute value of -5 is greater than negative absolute value of -5. The bars change everything. Now try this one on your own for a moment. Compare -9 with negative absolute value of -9. Pause the video, work it out, then come back. Here we go. The left side is just -9. The right side, inside gives 9, outside minus makes it -9. So both sides equal -9. They're equal. One more skill. Absolute value bars work like grouping symbols, like parentheses. We simplify inside first, then take the absolute value, then handle anything outside. Let's try absolute value of the quantity 9 minus 3. Inside first, 9 minus 3 is 6. Then absolute value of 6 is 6. Done. Now try 4 times absolute value of -2. The absolute value of -2 is 2. Then 4 times 2 is 8. You just unlocked how the number line handles positive and negative numbers, how to find opposites, and how to measure any integer's distance from 0 using absolute value. That's a huge piece of the integer puzzle. Next time, what happens when we start adding and subtracting these integers, and why does subtracting a negative flip into something that looks a lot like addition?